So welcome to the other side. Just like we said, we were looking at a map that was we're actually looking at a map. If you look at the map very well, okay, thank God I can even let me enlarge. At least we have seen this. We were looking at the map. I want to see if I can actually increase. Okay, let me enlarge it. I want us to look at, we've seen the map, we understand. We've seen some areas having red zone, which shows that they have high, actually the title of the map is PV power potential. So you should know that this map helps you in knowing the potentials, the solar potential of a particular place. We're using Nigeria as a case study, you understand. If you look at Connaught, that's where the sun hits very well. So then if you look at the extreme end, the coastal areas, Lagos, Port Harcourt, all those places, you discover that they are on the green zone here of the chart. So if you look at this chart, and I want us to understand something, please. How do they come up with these charts? We have never asked ourselves. How do they come up with this chart? Please, if you look at, you see long-term average of PV output. One of the best ways to get a PV potential of a place is to measure the reading over a period of time. You understand? If you say, okay, if I have a solar charge controller, you know, our solar charge controller actually gives us through a value of power generated daily. I don't know if you guys used to walk around these things. You guys, you need to move around, as in navigate in the solar charge controller to see all these things. It tells you how many quantum of energy you are able to generate per day. You understand? Depend on sunny days, you see that it generates, you see that it may be able to generate so, but on less sunny days, you see that the kilowatt hour generated will be less. I don't know if I'm the only person that navigates in all these things. You understand are you with me?
Yes, we are with you.
Good. So if you measure this, if you take the reading of this thing over a long period of time, let's take, for example, I take the reading every day for a year. You know, by the time I take the average, I will be able to get average value of power generated per day. You understand? And the longer the time I take these readings, the more accurate from mathematical expression. I don't know, from our mathematical point of view, the longer you keep taking data, you understand? If I'm taking data, if I take data for 2 days, and somebody, if I take data of my solar, let's say, for example, I have a solar, I take data today, it generates 5 kilowatt. The following day, it generates 3 kilowatt. You know, if I want to get the average, I'll just say 5 plus 3 divided by 2. I got 4. I will be convinced that my solar should be able to generate 4. You understand? I may not be very accurate like somebody who generated over a period of 365 days. You understand? He will be more accurate. And somebody that generated it for years will be much more accurate. The larger the data, the more accurate you get the result. You understand? So if you look at this long term, that one of the best ways to get this thing is, the best way to get a solar output potential for a place is to take the reading over a long period of time. You understand? So if you look at it, long-term average of PV output period from 1994, they were taking this reading for these places. So are you with me? From 1994 to 2018. So, and this is the result.
We're here.
This is the result they got. So you see, this is actually a long time. So then that means the result will be accurate. You understand? Will be very, very accurate. It will not be 100% accurate, but will be near enough accurate. And the more you take the data, the more accurate it becomes. So if you look at it now, the green zones here, if you look at something, I was explaining something to you guys earlier on. I said what it means kilowatt per kilowatt hour per kilowatt of power. Hour and power. This kilowatt hour is unit of energy to be generated. You understand? Just like we have our kilowatt hour as the generated quantity of electricity you buy. So the same thing is kilowatt hour per kilowatt of power. So if you have 1 kilowatt power, 1 kilowatt of power, in this green zone here, Lagos, all those coastal areas, it means you'll be generating around 3.2 kilowatt hour per day. 1 kilowatt of solar system around the Nigerian coastal area will only generate 3.2 kilowatt hour of energy. I don't know if you are clear.
Clear.
We are clear, sir. That means you are trying to tell us that the capacity maybe of our solar system PV, if it is 1 kilowatt hour in a day, you should be
1
able to
kilowatt, sorry,
accumulate 3 point.
1 kilowatt. You know, they are measured in
Yes, 1
kilowatt.
kilo. Yeah, 1 kilowatt hour PV value
No,
should
one,
be able to
Hela,
generate
Hela,
3.
sorry,
Yes,
let me
yes.
clarify something, please. Don't add the hour when you are calculating, when your capacity of solar power is wattage, you understand?
Yeah.
So it
It's
should be
okay.
kilowatts.
Okay.
So you are saying something.
Yes, 1 kilowatt of PV should be
Yes.
able to generate 3 point something kilowatt hour of energy in a day. That means from, let's say, morning to evening.
Good. Excellent. That is what it means. So if you come to the yellow zone, you understand? If you come to the yellow zone around here, you know that if you install a 1 kilowatt hour, 1 kilowatt bat of solar, it should be able to generate 3.6 kilowatts of power. So you see, as you're going up, fortunately, Maiduguri, where you are, Hela, if you have a 1 kilowatt hour, 1 kilowatt power of 1 kilowatt of solar capacity, you should be able to generate 4.8 kilowatts. This is very much achievable because I do achieve it here where I am, you understand, which is somewhere around north central Nigeria, you understand. I do achieve 4.8 kilowatt on a 1 kilowatt hour system. So I know in Maiduguri is very, very much achievable. Though these are average values, average value, it may go higher, you understand, and it may go lower. But the average value you get in such places, if you run this solar power for over a period of time, this is what you are going to be getting. I don't know if it's clear, please.
It's clear.
Okay. Is it very clear to all others?
Yeah, it is.
Okay. So now I think let's go into let me share another slide. Let me stop sharing. Is this diagram very clear? Or I will still share it on our WhatsApp platform, you understand? So that you people can, because this diagram is very essential for any solar power system design, you understand? The essence of this meeting or interactive session is we want a situation whereby good solar guys will be how do I call it? Will be nurtured or will be trained, or we understand we need to be very, very professional in handling all these things. So if you look at this guy here now, if you look at this diagram now, I will share this diagram so that you guys can go through the diagram. If anybody has any question, he can also share it on the platform. You can ask on the platform. So now let's look at the next thing we're going to be doing. Where is our basic components? Okay. So fine. So what is that for? That is that for it. So I think another thing that we need to ask or we need to know very well is, please, we should be very mindful. This power generated on this map is not like if you go and put your solar panels vertically. I don't know if you get the point. It will generate that too. Are you with me? If you know, solar panels have the best way they are to be installed. Solar panels have the best way they are to be installed. You understand? Solar panels you have to install them in a way such it has a way of you installing it to get the best possible outcome. You cannot just go say, I want to, since I have looked at this solar atlas and I have seen that I've looked at this solar atlas. I have seen that if I'm in Maiduguri, because I will always be making a reference to Maiduguri, where my brother is, or my brother and my fellow colleague he's there. And because there's so much sun in Maiduguri, if he carries his solar panel and hinge it by the wall of his house, he's going to harness 4.8 kilowatt hour per day. That is not applicable. That is not possible. Are you with me, Hela? Are you with me? Is everybody with me? Is anyone with me?
Yeah,
Yeah, we're here.
here.
Okay. So solar
The
panels.
sun is, very much here.
Today there's sun too much. You have too much sun there today?
I have to leave my room.
There's so much sun.
There was so much sun today.
Yeah, that's lovely. So that means you can easily generate 4.8 kilowatt today. So, but what we were
Even
saying.
if you
So what we were saying is you cannot say, because Maiduguri has a very good solar PV power potential, you'll just go and place your solar vertically, you understand, and you will you will harness 4.8 kilowatts in a day, you understand, from your 1 kilowatt of PV capacity. It's not possible, because there are ways you have to install solar panels for what? For maximum efficiency, for you to get the maximum output, for you to be able to get the best out of that solar panel. You have to install it properly, you understand. So those are some of the things, you understand. Can anybody share with us from, maybe those are guys from the former class, what is the best way to align our solar panels for us, looking at Nigeria as a case study? For us in Nigeria, what is the best way for us to install our panels, you understand? What is the best way for us to install our panels in Nigeria? Can somebody remember from the previous class? Or anybody that has any idea, can you share with us, please?
I think we have to, first of all, take note of the sun part. That is the sun direction.
Okay.
Why the sun is moving.
Okay.
The next thing maybe will be the angle at which it will be inclined, but I don't know that one.
Good. It's good, Hela. You see, there's a basic logic, you understand? There's a basic logic for us in this part of the world, you understand? We that are in the we're in the northern hemisphere, right? We're in the northern hemisphere, yeah. We're in the northern hemisphere, the equator coast across. We're in the northern part of the world, you understand? So for us in this part of the world, if you want to install your solar for proper energy, for you to harness the energy maximum, or for your solar to work efficiently, solar system to work, PVs to work efficiently, what you have to do is number one, it has to be south facing. You have to face the south. Look for your compass, or look for your phone, or you understand? You should know which direction is the south, and you face it towards the south. Angle of inclination depends on location, understand? The angle of inclination in Maiduguri and the Mayola and Lagos are not the same. We will come to that in our next class, you understand? We will come to that in our next class. But if you're in this part of the world, the best way to install your PV is for it to face the south, to be facing south, you understand? So that is it. For angle of inclination, we will be talking about that one next week. You understand? So I don't know if there's any other question, any other observation, any other this thing. So we are starting next week from how to get our angle of inclination for a particular location, you understand? Then we will now look at what are other constraints we face. What are other constraints we face when installing this solar panel? You see, I would like to tell you that a lot of the solar panels are installed, we install them on our rooftops, and most of those rooftops were not designed for solar panel installation from the beginning. So, but you understand my point? When most of these our houses were built, some of our houses were built for aesthetics, you understand? So we didn't think of, okay, in the near future, we may use solar panels on those rooftop. But because today we need solar, we need power, we just install them because they are the available space we have. So all these things affect efficiency, you understand? They affect the efficiency. So I will advise, presently, if you're building any home or you're building any house, I will advise you to also always factor this in, put this into consideration. You should have a large space that is south-facing. Possibly, let the inclination angle be consistent with the best angle for your solar panels to be installed so that you will utilize that space for your solar panel installation, you understand? So we will talk about that, inclination angle, how best to do, what are the best possible ways to install these solar panels to get the maximum efficiency. We'll talk about that next week, please. So any other question, contribution, or whatever, or were we able to make sense today? Hello? Hello?
Well, nothing from my side.
Okay, nothing from your side. That's fine. So before we go, I think we can just quickly, at least we can just quickly have a recap of what we actually studied today so that we continue from there to next week, Sunday, by the grace of the Almighty. So let me share our, okay. So at least we talked about basic components. Today we talked about just two aspects of the first part of the course or first part of the meeting. We talked about the basic components of the inverter solar power system. Then we talk about the radiation of the sun power at various locations, you understand? So next week we will still elaborate, we'll still talk more about this radiation of sun power at various locations because it's somehow a bit, that is one of the issues we actually have when installing these things, you understand? We have to look at it very, very well because this time around, it's actually going to be more of a practical course because we have a lot of engineers that are actually practicing in this forum. So if there's nothing, I think we can call it a day and hope to see ourselves, or we hope to converge again next week. I will still share the link like I did today on Saturday or on Sunday next week. So from me, I think it's a goodbye. I don't know.
From the hottest part
Thank you
of
so
Nigeria, Maiduguri, it's bye-bye.
Okay, thank you.
All right. Thank you, guys. Thank you, engineer.
Thank you, guys. Thank you. So take care.
Thank you.
I think you can share your Gmail if you have a Gmail so that at least if you are interested in the videos, because the video will be shared, so that I can actually share the link for you to access the videos, you understand? If you what we actually did today, that is if you're, and I will also put it on the platform so that anybody that is interested can actually pick it up for his own self-study or for his own follow-up or for reference. So thank you very much, sirs. Engineer Iluan,
Thank you for your sacrifice.
Thank you for
appreciate.
Thank you for our sacrifice. Haji Iluan, thank you, sir.
Thank you.
Yes, sir.